now we are going to look at another type of force, that is frictional force. When a body of mass m is kept on a rough surface and acted by a force capital F in rightward direction, then because of bonding between the block and the surface, a frictional force acts parallel to the surface in opposite direction, which tries to oppose the relative motion between object and the sliding surface. The moment till block remains at rest, frictional force is known as static frictional force, and when block starts sliding on the surface, the frictional force is known as kinetic frictional force. Now first look at some properties of frictional force. Static frictional force is a self-adjusting force. When we keep on increasing the value of applied force, the value of static frictional force also keep on increasing. When applied force remains zero, static frictional force also remains zero. The maximum value of static frictional force till block do not get slide on the sliding surface is known as limiting frictional force or maximum value of static frictional force. The maximum value of static frictional force is represented by FL, small f. FL means limiting frictional force, whose value remains equal to μs into n, where μs is coefficient of static friction and capital N is the normal reaction exerted by surface on the block. Now what happens when the applied force becomes more than limiting frictional force? When applied force becomes more than limiting frictional force, the block starts sliding on the sliding surface. Now what are the values of frictional force in various cases? Remember, when applied force is zero, the static frictional force is also zero. When applied force is less than limiting frictional force, then frictional force is equal to applied force, which is less than limiting frictional force, and it is static in nature because block is not moving. Now, when applied force becomes equal to limiting frictional force, then frictional force is still static in nature, and its value in this case equal to applied force, which is here equal to limiting frictional force, that is equal to μs n. Now, when applied force becomes more than limiting frictional force, the frictional force is equal to Fk into n, where Fk is the kinetic frictional force and μk is coefficient of kinetic or dynamic friction. Mu k is coefficient of kinetic or dynamic friction. Since mu k is less than mu s, so kinetic frictional force always remains lesser than limiting frictional force. If we make the graph between frictional force and applied force, this will be as shown in the figure. As far as static frictional force is concerned, it will have definite slope as shown in figure, and after achieving the condition of limiting frictional force, the frictional force reduces little bit and then again becomes horizontal. Means when the block starts moving, kinetic friction acts, whose value remains constant and remains lesser than limiting frictional force as shown in figure.